Welcome to Junior Mobile App Development with Flutter. If you have ever wanted to learn how to build your own mobile applications, but felt unsure where to begin, this course is designed exactly for you. In this course, you will be introduced to cross-platform development using Flutter, one of the most popular frameworks for building apps that work seamlessly on Android and iOS using a single code base. We will focus on helping you build a strong foundation in Flutter and Dart through a clear, structured approach. The course is organized into 8 modules, with each module containing 2 to 4 subtopics that guide you step by step, making sure you do not feel overwhelmed as you learn to build and understand real-world mobile apps. Now, let's look at what you will achieve by the end of this course. By the time you complete this learning journey, you will have a solid understanding of the fundamental concepts of Flutter and Dart. This will give you the confidence to continue exploring and building on your skills independently. You will learn how to simplify complex programming concepts, such as object-oriented programming and state management, in a way that makes sense even if you are completely new to programming. You will gain the skills to design user interfaces using basic widgets and layouts, so you can create clean, structured, and visually appealing app designs that are functional and user-friendly. You will learn to implement basic state management and integrate APIs into your applications, allowing your apps to communicate with external services and handle data effectively. Most importantly, you will be prepared to handle real-world app development scenarios using Firebase, giving you a taste of how to build apps that are ready to be launched and used by actual users. Take a deep. Welcome to this lesson on Introduction to Flutter. This is where we lay the foundation for understanding why Flutter is such a powerful tool for building apps that people have to use. Let's start with what you can expect by the end of this lesson. By the time we wrap up, you will understand the core concepts and key features of Flutter. You will learn why Flutter is such a valuable and in-demand technology for mobile app development. And you will gain a solid grasp of the benefits of using Flutter for cross-platform development, helping you appreciate how it can simplify your developer journey. Now that you know what to expect, let's get into the heart of it. What is Flutter? At its core, Flutter is an open-source UI SDK developed by Google. This means it is backed by the resources and expertise of one of the world's leading tech companies, ensuring it is well-supported and constantly evolving. Flutter allows you to build natively compiled applications, which simply means you can deliver high-performance apps that feel like they belong on the device, with smooth animations and fast interactions, just like native apps. One of Flutter's most appealing strengths is that you can build your app from a single code base. You write your application logic once and can deploy it across multiple platforms, including iOS, Android, web, desktop, and even embedded devices with only minimal code changes. This enables you to reach a wider audience since your app can be made available across mobile, web, and desktop platforms without the heavy lifting of managing separate code bases. Now, let's continue and talk about Flutter's key features. First, Flutter's cross-platform development capabilities are a game changer. Maintaining a single code base for multiple platforms reduces development time and costs significantly. You save time and resources while being able to launch your application on different platforms simultaneously, helping you get your product to market faster. Next is fast development. Flutter's hot reload feature allows you to see changes to your code reflected instantly in your running application. This makes it easier to prototype and iterate rapidly, keeping your development process flexible and efficient. This feature increases developer productivity since you spend less time waiting for rebuilds and more time building on refining your app. Flutter also uses a declarative UI approach, where you define the desired state of your UI, and Flutter handles efficiently rendering the changes. In terms of native performance, Flutter delivers smooth animations, fast rendering, and a fluid user experience that feels natural on each platform. This is achieved by leveraging platform-specific rendering engines to optimize performance, ensuring your app feels responsive and polished. Another strength is Flutter's large and growing community. This means you will have access to a wealth of documentation, tutorials, and community resources whenever you need support or wish to learn something new. It is easy to find solutions and get assistance by engaging with the vibrant community of developers around the world. Now that you know the key features, let's dive into why Flutter is worth your attention. Flutter enables rapid development, accelerating your development cycles through features like auto reload, allowing for faster experimentation and delivery. This improves your developer experience by letting you focus on building and fixing features quickly and efficiently. It is also cost-effective. By maintaining a single code base for multiple platforms, you reduce development and maintenance costs, eliminating the need for separate teams for each platform. This leads to a faster time to market and requires less effort to keep your app updated across platforms. Flutter also empowers you to create beautiful user interfaces. You can leverage its rich set of customizable widgets and expressive UI capabilities to craft visually stunning and engaging user experiences that are consistent across all platforms. This ensures high quality and appealing designs for your users. Another reason is growing demand. Flutter is gaining popularity among businesses of all sizes, leading to increased industry adoption. This also means there is a high demand for skilled Flutter developers in the job market, opening doors for strong opportunities and competitive salaries if you pursue this path seriously. Finally, Flutter is open source and free, making it easily accessible to developers at any level. You can start developing with Flutter without worrying about licensing costs, making it a cost-effective and inclusive framework to begin your journey in app development. Let's take a quick moment to summarize what we have covered. Flutter is Google's open source UI SDK that allows you to build natively compiled apps for mobile, web, and desktop. Its key features include cross-platform capabilities, fast development with hot reload, expressive UI, native performance, and a strong community. The benefits you gain from Flutter include rapid development, cost-effectiveness, the ability to create beautiful UIs, and high demand in the job market. Before we close, let's reflect on a few important questions. What is Flutter? What are the key features of Flutter? How does Flutter enable cross-platform development? What are the benefits of using Flutter for mobile app development? Why is Flutter gaining popularity in the mobile app development industry? Take a moment to think about these questions, as they will help you solidify your understanding of why Flutter is such a valuable tool for modern app development. Now, if you would like to explore further and dive deeper into Flutter's practical benefits and considerations, here are some recommended resources for you. These resources would allow you to continue your learning, explore real-world examples, and deepen your understanding of Flutter's capabilities so you can confidently move forward in your developer journey. Thank you for... Now that you understand why Flutter is such a powerful tool for mobile app development, it is time to explore the programming language that powers Flutter, Dart. In this lesson, we will dive into Dart so you can start feeling comfortable reading, writing, and understanding Dart's code as you build your Flutter apps. By the end of this lesson, you will understand the fundamental concepts of Dart. You will learn how to declare and use variables with different data types and grasp the concepts of control flow, including conditional statements and loops. You will also learn how to define and use functions and methods in Dart, and gain a basic understanding of object-oriented programming principles within Dart, which will help you structure your apps in a clean and scalable way. To continue, let's talk about what Dart actually is. Dart is an object-oriented programming language, meaning it uses the concept of classes and objects to structure your code. It is designed for building fast, client-optimized applications, making it perfect for front-end development, including web and mobile apps, while also being suitable for server-side and back-end development. Dart was developed by Google as an alternative to JavaScript, providing a more structured and modern approach for developers. What makes Dart particularly appealing is its emphasis on clean code and developer productivity. This helps you write clear, efficient code that is easy to maintain as your projects grow. Moving on, let's break down some of Dart's key features so you understand why it is a solid choice for Flutter development. First, Dart uses strong typing. This means it enforces data type safety, which helps prevent unexpected behavior and reduces runtime errors. For example, int age equals 50 explicitly typed. Here, the compiler will not allow you to assign a string value to the variable age, helping catch errors early during development. Another powerful feature of Dart is asynchronous programming using async and await. This allows Dart to handle time-consuming operations like network requests without blocking the main thread. For instance, string result equals await fetch data. Using await makes your code easier to read while keeping your app responsive. Dart also includes no safety, helping you prevent no pointer exceptions, which are a common source of bugs in many programming languages. With no safety, you are required to handle no values explicitly, making your code more robust and less prone to crashes. Additionally, Dart offers fast compilation, which enables rapid development cycles. Faster compilation times mean less waiting and more time coding and testing your apps. It also improves application performance with faster startup times and smoother user experiences. Now that you understand Dart's key features, let's move into variables and data types. which form the foundation of any programming language. In Dart, you can declare variables in a couple of ways. Using var, Dart automatically infers the data type based on the value assigned. Var name equals John. Name is inferred to be of type string. Alternatively, you can explicitly declare the data type for clarity and safety. String name equals John. Int age equals 50. Double price equals 9.99. Bool is true equals true. Dart provides a range of data types. Numbers. Use int for whole numbers like -10, 0, 42, and double for floating point numbers with decimals like 3.14. Strings. Use string for sequences of characters. For example, hello or Dart is awesome. Booleans. Use bool for true or false values to represent logical states in your app. With variables and data types in place, let's move on to control flow, which helps you control how your code executes based on conditions. You can use conditional statements such as if, else if, and else to execute different blocks of code based on conditions. For example, if age greater than or equals to 19, print you are an adult. You can also use the switch statement to evaluate an expression and execute different blocks of code depending on its value, making it cleaner when handling multiple conditions. For repeating tasks, Dart offers loops. You can use a for loop to execute a block of code a specific number of times. For int I equals 0, I less than 5, I plus plus, print I. You can use a while loop to execute a block of code as long as a condition remains true, and a do-while loop, which is similar to while, but it ensures the block of code is executed at least once before checking the condition. Now, let's connect your understanding of control flow to functions and methods in Dart, which are essential for writing reusable and clean code. To declare a function in Dart that does not return any value, you can write void my function code to be executed. If you want a function to return a value, you can specify the return type. Int add, int a, int b, return a class b. In this example, the function takes two integers and returns their sum. When working with functions, it is important to understand parameters and arguments. Parameters are placeholders for values passed into a function, such as a and b and add int a, int b. While arguments are the actual values you pass when calling the function, like add 5, 3, where 5 and 3 are the arguments. Functions can return values of any data type. For example, string greet, string name, return hello, name. Here, the function returns a string greeting using the provided name. When functions are defined inside a class, they are called methods. Methods can access the properties and other methods within the class, helping you organize your code in a structured, object-oriented way. Let's summarize what you have learned in this module. Dart is an object-oriented programming language designed for building fast, client-optimized applications. Key features include strong typing, asynchronous programming, no safety, and fast compilation. You learned that variables are used to store data such as integers, doubles, strings, and booleans. You explored control flow concepts like conditional statements and loops to control the order of execution in your code. And finally, you learned about functions and methods as reusable blocks of code that can accept parameters and return values. To help solidify your learning, reflect on these questions. What are the key features of the Dart programming language? How does strong typing help prevent errors in Dart? What is the purpose of asynchronous programming in Dart? What are the different data types available in Dart? How do you declare and use variables in Dart? Explain the difference between if-else and switch statements. How do you define a function in Dart, and what are parameters and arguments? What is the difference between a function and a method in Dart? Take a moment to think about your answers or note them down to revisit during your practice exercises. If you want to explore Dart and Flutter further, here are some additional resources that will help you dive deeper and expand your practical understanding. These resources will guide you with examples, tutorials, and industry insights that you can apply as you continue building your Flutter development skills. Now that you have a grasp of Dart basics, it is time to take your development skills a step further by learning about Object-Oriented Programming, or OOP. In this lesson, you will learn the core principles of OOP and see how these principles help you structure and manage your Dart code effectively. You will learn how to define classes, create objects, understand encapsulation, inheritance, and polymorphism, and apply these concepts to design and implement clean, reusable Dart classes. Let's start by understanding what object-oriented programming actually is. OOP is a programming paradigm that structures your code around objects, which represent real-world entities like a person, a car, or even a button on your app's screen. This approach helps you make your code more organized, reusable, and easier to maintain, which becomes especially important as your projects grow in size and complexity. Now, let's break down the key features of OOP so you can clearly see why it is such a powerful approach in programming. First, you have classes, which are blueprints for creating objects. They define the properties, which are your data, and the methods, which are the behaviors of the objects. Next, you have objects, which are instances of these classes. Each object will have its own specific values for the properties defined in a class. Encapsulation is another important concept, which means bundling the data and the methods that operate on that data within a single unit, the class. This also introduces the idea of data hiding, which protects the internal state of an object from unauthorized access. you will also learn about inheritance, which allows a class to inherit properties and methods from another class known as the parent class. This promotes code reusability and creates a hierarchy of classes, making your code cleaner and more organized. Finally, there is polymorphism, which allows objects of different classes to be treated as objects of a common type, giving you flexibility and extensibility in your code. Now that you know the key features, let's see how classes are defined in Dart. Classes act as blueprints or templates for creating objects, defining the properties and methods that objects of that class will have. For example, you can define a simple car class like this. Class car, string color, int speed, void accelerate, code to increase the speed. Here, color and speed are properties, while accelerate is a method that would increase the speed of the car. Building on that, objects are instances of your classes. And each object will have its own unique set of property values. For example, car, my car equals car. My car.color equals red. My car.speed equals 0. Here, my car is an object created from the car class with its own color and speed values. Let's now explore encapsulation in Dart. Encapsulation means bundling the data and the methods that operate on that data within a class, while also protecting the internal state from unauthorized access. This protection, or data hiding, is achieved using private members, which you can declare with an underscore before the name. Access to these private members is managed through getters and setters, allowing you to control how data is read or modified. For example, class person, string underscore name, string get name underscore name, set name string value, underscore name equals value. In this example, underscore name is a private property, and controlled access is provided through the get and set methods. Next, let's look at inheritance in Dart. Inheritance allows you to create a new class, known as a subclass, from an existing class called the superclass. This means the subclass inherits properties and methods from the superclass, promoting code reusability and a clear hierarchical structure. Here is an example. Class animal, void make sound, print animal makes a sound. Class dog extends animal, at override, void make sound, print wolf. In this example, the dog class inherits from the animal class, but overrides the make sound method to provide its specific implementation. Following inheritance, we arrive at polymorphism in Dart. Polymorphism enables you to treat objects of different classes as objects of a common type, which increases your code's flexibility. One way polymorphism is used is through method overriding, where a subclass provides its own implementation of a method that is already defined in its superclass. Another way is through interfaces, which define a contract that a class must adhere to, ensuring consistent behavior across different classes that implement the same interface. Polymorphism allows you to write more flexible and extensible code, which is crucial when building scalable Flutter apps. Now that you understand the principles, let's highlight the benefits of using OOP in your Dart and Flutter projects. OOP improves your code's organization and maintainability, making it easier to understand, modify, and debug. It increases code reusability, helping you reduce duplication and improve efficiency. OOP also enhances flexibility and extensibility, making it easier to add new features and adapt to changing requirements as your projects grow. Let's recap what we covered in this module. Object-oriented programming organizes your code around objects. You learned that classes are blueprints for objects, containing properties and methods, while objects are the actual instances of these classes. Encapsulation bundles data and methods within a class while protecting data through hiding. Inheritance allows you to create new classes based on existing ones. And polymorphism allows you to treat different objects as a common type, giving your code flexibility. Using OOP principles will help you write organized, reusable, and flexible code, making you a more effective Flutter developer. Before we wrap up, take a moment to reflect on these questions. What are the key benefits of using OOP principles in software development? Explain the difference between a class and an object. How can you achieve data hiding in Dart? What is the purpose of using inheritance in Dart? How does polymorphism improve code flexibility? These questions will help you review and apply what you have learned before moving to the next lesson. If you want to explore OOP in Dart even further, here are some recommended resources. These resources will give you additional examples, in-depth explanations, and practical exercises to help you strengthen your understanding and confidently apply these principles as you build your Flutter projects. Thank you for joining this lesson. You are building a strong foundation that will allow you to write clean, organized, and reusable code in Dart as you continue to grow as a mobile app developer with Flutter. Take your time to review, practice, and explore the recommended resources, and I look forward to seeing you in the next lesson as we continue your Flutter development journey together.